Let's talk about types of equipment grounding conductors. Now, we haven't talked about types. We've talked about equipment grounding conductors in a theory way, conceptual way, even EGC showing some pictures. So let's talk about what is considered an equipment grounding conductor. All right, first of all, let's get the definition. Now, this definition is wrong, and it doesn't make any sense. So I'll explain to you why it's wrong, why it doesn't make any sense, but what is it trying to accomplish. And we talked about this morning in the team, and we can't figure out a way to make it better. So we have to go with the definition that we have. So let's see if we can talk about this. The definition says of an equipment grounding conductor, the conductive path that is part of an effective ground fault current path. And I showed you this. I say, guys, you know, electrons leave the source, go to the meter can, go to the main breaker, go to the panel board, go to the branch circuit protection device. There's a ground fault. Actually, ground fault current doesn't go to ground, guys. Don't worry about that. Okay, current is returning out of this. Here is going across this equipment grounding conductor, coming along here. Here's an equipment grounding conductor. Go to main bonding jumper, connects up with the neutral, returns back here. Guys, all this green stuff here, all this is called an effective ground fault path. Okay, and Eric said, well, Mike, don't forget that it has to be intentionally constructed. And Mario said, hey, it's going to have a low impedance path. Oh, no, Mario said it has to have the capacity to carry the fault current likely to be imposed. It has to be a low impedance path. Part of the definition of the effective ground fault current path is that it's from the point of a fault back over to the source. So we have the fault point of force back to serve. It's intensely constructed, has the ability to carry the fault current, has a low impedance path, and then it also says what else? What's the purpose?
To clear overcurrent protection.
To clear the overcurrent protection device. So that's a lot of stuff on there. And part of this effective ground fault current path is that equipment grounding conductor. Now, we would like, Eric, that the main bonding jumper would say it's part of the equipment grounding conductor.
Right.
I mean, the effective ground fault current path. We would like the neutral would be possibly part of the effective ground fault current path. But it doesn't say that. But it does say that the equipment grounding conductor, when we get into effective ground fault current, is part of the effective ground. Okay, and here's what it gives. The conductive path. So what's an equipment grounding conductor, Mike? The effective path that's part of the effective ground fault. Oh, yeah, that's right. That's part of that. That's part of it. Okay. And connects the metal parts. Yep, these are the metal parts. It's connecting these metal parts of equipment. That's bonding, okay. Together, okay, that's bonding, right? Oh, sorry. And you make that connection back to the system neutral. Well, that equipment grounding conductor stops right here. Then we go to the main bonding jumper. Then we go to the neutral. So the only way it can connect to the neutral is through the main bonding jumper. So, yeah, it's connecting to the neutral through the main bonding jumper. And that is at a service. How about a transformer? Well, the electrons leave the source. They go to the overcurrent device. It's a ground fault. I like that. We don't even say it's a ground fault. We just show it. Then the electrons travel on the enclosure. It travel on the equipment. Oh, I like this. Look at this color, Mario. Look at that color. Not the same color. I like that, Brian, that it stands out slightly different color than the other ones. And I like the size of those. You see what I'm saying, Mario?
Yeah, I see what you're saying.
So that is the equipment grounding conductor. And I like that size as opposed to that size is like, little Russian version there. Okay. All right, so current leads the source, goes to the overcurrent device. Here's a ground fault. Fault current's going to go back to the source. It travels on the equipment grounding conductor. Remove these bonding jumper things. I don't know what the heck those things are there. Okay, then the equipment grounding conductor is right here. Oh, yeah. Remember, John, this wire here is before the overcurrent device, so this is a supply side bonding jumper. Mm-hmm. And we had to go to 250.102C, which dealt with supply side bonding jumpers. Mm-hmm. And then it goes back over here, and we had not talked about this wire, but this is a system bonding jumper, which we're going to talk about this. But without talking about this is part of the effective ground fault current path. So now for equipment grounding conductor, it's the conductive path that is part of the effective ground fault current path. Right there, it's part of it, okay? And connects metal parts of equipment together, which is bonding these things together, to the system neutral. Well, this goes over here. Then it's going to a supply side bonding jumper. And then it's going to a system bonding jumper, and then it gets over to what is called the neutral point. Doesn't really get to the neutral conductor. but it's trying to say what we're showing. But John, do you understand that bonding all these things together and connecting it like this here provides the effective ground fault current path?
100%.
And that this is part of that effective ground fault current path.
Yes.
If I could just say that together and put a period there, you know what I mean?
Yeah.
Then I wouldn't have to say about, and if I can come over here, do you understand that this fault current, this is the effective ground fault current path?
Mm-hmm.
And that this is part of it?
Yes.
And I think I'd rather just stop right there.
Yep. Perfect.
And not go any further. Mario, let's do that in the textbook, let's do it in the graphics, without getting into the neutral connection.
So stop at metal parts of equipment together?
Yeah. Yeah.
Okay.
Yeah, and then not getting into the details. Okay, so now we know what an equipment grounding conductor intended purpose is, and or rather what it's called. Now let's review again what we've done before. Well, if there's a ground fault current leaves the overcurrent protection device, it goes to the ground fault, electrons leave, they travel on the equipment grounding conductor through the supply side bonding jumper, which we'll talk about later on, the system bonding jumper, which is part of the effective ground fault current path. And if we know the resistance of the hot wire and we know the resistance of the return path, if we take the resistance of 200 feet of 3-gauge wire and a 100 amp breaker, Eric, we go to table 250.122. It said you can use an 8-gauge wire, which would be smaller than the phase conductors, right, guys? Then you go to chapter 9, table 9, you get the resistance of the hot wire, you get the resistance of the return wire, equipment grounding conductor, you add them together. We go to Ohm's law, but it's alternating current. We use Z. We covered that in theory. 120 volts divided by the impedance, 583 amps on a 100 amp breaker. We kind of, let's think about that, 500. Okay, what's 583, 100 amp breaker at the multiplier of about what?
5.86.
6 times. And I think Brian, Tom Dimitrievich, we kind of went around there. Not likely that you're going to go in the instantaneous range. Remember the time current curves? Well, 20 amp breaker, 40 amps, supposedly a half a minute to 2.5 minutes, 100 amps, maybe 5 seconds to 20 seconds. And now we're not instantaneous.
That one might take a few seconds to clear.
Right.
Yeah, I mean, it might
Almost
not
600
pop.
volts. Wow.
Yeah, this might take
600
a
amp.
while. And time is a function of heat in addition to current. So this could be some problems here. So either way, we do know this though, that 583 amperes is going to open the 100 amp breaker eventually over some given period of time. Mm-hmm. Now this is code sized, right? We sized the equipment grounding conductor based upon the code. Now remember 250, we didn't talk about it, we'll do it a little later on, maybe a little bit. 250-122, we had a note, Mario.
Bottom of the table?
The bottom of the table. They said, well, Mario, why don't you read 250-120? If we size it to the code for a 200-foot run, it's going to give us an impedance of this value, which gives us 600 amperes. What's a note of table? Is it a note number, 1, 2, 3, 4?
There's only one note, so it's just note.
What's the note?
So the note to table 250.122, where necessary to comply with 250.4A5.
1 second. 254A5 was the rule that said that you had to have an effective ground fault current path. And it goes on there about low impedance path, to trip the overcurrent device, and it gets into all, in order to comply with that, go ahead.
The equipment grounding conductor shall be sized larger than given in this table.
It even says shall be sized. This is not like an informational note. This is telling you, you're gonna have to make it bigger than this. Now, Eric, you're an engineer. You're an engineer in the team here. Is that going to meet 250.4A5?
Nobody knows.
Nobody knows.
Because 250.4A5 has no requirements in it. It just says, okay, it's got to trip the overcurrent protection. But it doesn't say it has to trip within 3 cycles. It doesn't have any requirements in there per se.
So the answer is yes. It's fine.
Yeah, it's fine.
Yeah,
because
it's fine.
we don't know.
Because we don't know what's not fine.
Right.
And we
It
went to the
doesn't say.
code, and we don't know how to make it shall be better. So, but let's go back to our, all right. If we size it to the code, it comes out to be, in this example, 600 amperes. It's going to trip this device. That's an equipment grounding conductor. That's the purpose of the equipment grounding conductor, to be part of the effective ground fault current path. Now, what are the different types of equipment grounding conductors? That's where this list of 14 items comes in. Well, you ran PVC. Obviously, it's not conductive. We're going to have to run a wire. Rigid metal conduit, we're good. IMC, don't worry about it. We're fine. EMT, it's metal. Come on, guys. The metal guys are fine. Don't worry about those. That's an equipment grounding. Flex metal conduit, well, we have some limitations on that, because it's flex interlock. It's a liquid type flexible. Well, liquid type flexible, again, some limitations. Romex, well, that's a wire. How about MC cable? Well, you have a green wire in MC cable. What about the MC all-purpose cable from Southwire? Well, it has a 10-gauge aluminum bonding strip, and we'll talk more about that. So that's your equipment grounding conductor. How about armor cable? Well, it has an 18-gauge aluminum bond. Oh, no, this is a 10-gauge aluminum bonding grounding conductor. And Mario changed this to this is a bonding strip on this AC cable. That's not a bonding conductor, it's a bonding strip.
Okay.
So these are options. So now let's go to the list. 250-118, that was kind of like a summary, or rather an introduction. 250-118A1 says, well, an equipment grounding conductor can be bare or insulated. Solid, stranded, doesn't matter. Okay, so I can use a wire. You can see here. Bare, okay, got that. That was one. Number two, rigid conduit, right? The conduit itself. 3, intermediate metal conduit. 4, EMT. It's interesting. So funny to watch social media. I'll show a picture and I'll show that the box and it has EMT connected in there. Where's the where's the ground wire in the pipe? And I'm like, any real electrician would always put a bond wire in the pipe. And I'm always sitting like, what the heck do I do with this guy? What do I say? You know what I mean? And usually I'll respond something and say, well, that's the minimum code. I'm like, no, it's not the minimum code. That's the safety code. The code is not a minimum. It's a safety standard. Then he goes on. I'm like, okay, so do you put 2 bond wires, or do 2 ground wires in PVC? Do you put like 10-gauge wire on a 15-amp circuit? When do we get this minimum, that kind of silly
Yeah,
stuff?
right.
So there are people out there that do not like the metal raceway to serve as the equipment ground. Well, I'm okay with rigid, that EMT, no. But I can understand, because there are industries out there that these guys might be working in, that they have forklifts, they have equipment, and there's damage to rigid metal conduit. So those guys that are working in that world, or all their life, they've always put an equipment grounding conductor inside of a metal raceway because they're always spec'd out. I mean, that's the world they've worked from. They just can't imagine that. Of course, they couldn't even conceive the concept of running Romex, much less in Chicago. I mean, this is like, do you guys have a requirement in Chicago? Or research, do you know if Chicago has a requirement to have an equipment grounding conductor in metal raceways?
I know they do not do that in residential, but I would have to dig into their code to see about other spots, but I doubt it.
So you know all about the electrical code, but not the Chicago code.
I don't use it. I'm 90 miles away.
Okay, all right, so we go back to where we got here. Okay, so this is what the code says is suitable. You don't need to put an equipment grounding conductor inside of an equipment grounding conductor for rigid, for IMC, for EMT, flex. Here are the conditions on flex. You can use flex if the raceway terminates in listed fittings. Okay, well, what do you mean if the raceway terminates in listed fittings? The fittings are listed. So if they terminate in fittings, okay, well then why are you even saying it? Okay, fine. We'll still leave A in there. The circuit protection is protected by an overcurrent rated 20 amps or less. Okay, I want to say more than 20 amps. Okay, so if it's not more than 20 amp circuit, you're fine. Also, that the flex is not large 1.25 inch. I don't really care if it's larger than 1/4. It's a 20 amp circuit. I mean, who cares what size pipe you're running in there? Okay, fine. If anything, I think if bigger would be better, but it doesn't really matter. The combined length of the flex and the fall path does not exceed 6 feet. Okay, 6 foot combined length, 20 amp breaker. That's when you can run flex as an equipment grounding conductor. Okay. Now, it goes on, it says, however, if flexibility is required, an equipment grounding conductor or a bonding jumper of the wire type must be installed. So if you have to have flexibility, if it's required, well, who makes that decision? Well, I didn't have to have it. Okay, well then you don't have to have an equipment grounding conductor. You know what I mean? Well, I had that. Well, no. So the key there is that if it's flexibility is required. Liquid tight, it's a little different. Liquid tight kind of goes on to different size liquid tight. all both 6 feet. But if it's up to ½ inch, which we're not running, Mario, get rid of the 3/8. We don't run 3/8 Liquidite. Make sure in our book we don't talk about 3/8 Liquidite.
Right.
If it's ½ inch Liquidite, no more than 6 feet, no, and then don't say 15 or 20, just say maximum of 20, right? Maximum of 20, not more than 6 feet, ½ inch Liquidite is good. Metal conduit. If it's larger, if it's 3/4, 2 1 1/4, not more than 60 amps, then it can serve as an equipment grounding conductor. Armor cable. This is the aluminum with an 18 gauge aluminum bonding strip. See, this bonding strip bonds the convolutions of each of these
Corrugated.
Not corrugated.
There's a word I want.
Spiral wrap.
Interlocked.
The interlock,
yeah.
spiral interlock, whatever. So the convolutions. I'm looking. Yeah. The spiral interlock so that's going like this here. Okay. So the actual sheath is not listed as an equipment grounding conductor for armor cable, but this 18 gauge aluminum bonding strip which touches each convolution, and that making contact, that is what bonds this convolution to the next convolution all the way down the line. And when you get to the end here, you just cut it off, right? I would cut it right off right there 100% of the time. John.
I wrap the redhead with it every single time.
What happens if you don't wrap the redhead to it? Will it fall off?
Yeah, I mean, it could. I mean, it's not a big deal if you're saying that. I mean, if it's listed for it, then that's what you got to do. But I just do that to keep that in there, just because.
Okay. Now, when you use armor cable, you have to terminate it in fittings that are listed for armor cable.
Right.
And they're designed to keep the redhead there. But electricians, they don't know what to do with the wire. They got to do something. You can't just cut it off. I would cut it off just to drive people nuts.
Just to drive people nuts.
Just to drive them nuts. And I'd figure out how to hold the redhead in there if that was a problem, okay? Because, see, John, it served its purpose.
It did.
The moment it came out of the cable, right, it served the purpose of bonding each convolution to each convolution. The combination of the steel interlock with the bonding conductor makes that outside sheath an equipment grounding conductor. And that's what that takes care of. MC cable, well, the outer sheath is not listed as an equipment grounding conductor. And if it has no bonding conductor in it, well, then you'd have to put a green wire in there, and that's how we do that. They do make MC cable, that has a 10 gauge aluminum bonding strip. Now this, can't say it. This is a 10 gauge aluminum bonding grounding conductor, and it's marked. Well, here, armor, okay. Armor suitable as equipment grounding conductor. And so this, Mario, take a look at some of the old graphics. We used to show dotted lines that went across here, and I don't see them anymore. And this 10 gauge wire connecting to each convolution is what bonds each convolution, which makes the sheath with the combination of the grounding bonding conductor. This makes this an equipment grounding. Mario, let's put on there equipment grounding conductor on here. Let's put on here equipment grounding conductor, right, on the sheath, right?
Well,
Just
not on
EGC.
that. Not on that one, right?
Oh, I'm sorry. An equipment grounding conductor, EGC right there, not on here. We could put on here EGC, right?
Okay.
Here we could put EGC, right? Could that be an equipment grounding conductor? Now, what do you do with this wire, the 10 gauge wire, with the instructions tell you, you bend it back 120 degrees and you cut it off. Now, because guys have been using armor cable for so many years in some parts of the country, and they take it and they put it behind the redhead, okay? So when it gets to MC cable, I don't know if you know this, John, you don't need a redhead or an anti-short bushing on MC cable.
I know that.
Okay, but guys are putting anti-short bushings on this, and what do you think they do with this 10 gauge aluminum wire? They do not cut it off because they take that 18 gauge, they wrap it around. They're taking the 10 gauge aluminum wire and they're trying to do the same thing they used to do with the 18 gauge aluminum wire.
Big.
And then they get the connector, then they're trying to put the wire that did not have a 10 gauge wire outside the cable, trying to put it in a connector that was designed, and trust me, are they gonna get it in there?
Oh yeah.
Oh, yeah.
Okay, so we know it's going to get in there.
Might not be a connector left, but that wire's going in there.
The wire's getting in that box.
Going in
And
that
then
baby.
usually what they do is they wrap it around.
The convolution.
They wrap it around.
They wrap it around the convolution. Okay, that one didn't go that way. So we're going to kind of suck it in here and then just kind of go around there. And okay, so back to where we are here. So you cut it off, and you bend it back 120 degrees, you cut it off, and you're done. Okay, You can use cable tray. The actual cable tray itself can serve as an equipment grounding conductor. Now, what that means is this. You have the cable tray serving as an equipment grounding conductor, which means you can run conductors in the cable tray. And then when you kind of drop down the supply equipment, you then bond onto the tray and you bring a green wire, let's say, and you go to the equipment. Eric, is it, now you have to have special cable tray. This is not any cable tray. Okay. Eric, is this done in reality using the cable?
We never did it, and when I worked for the chemical plants, we never did it because it's too much of a hassle. Because you have cable trays, usually also can run long distances. You have expansion joints. You got to bond around those. You got discontinuities. It's just, nah, we're not going to do it.
Research, and what's your experience on cable trays used as an equipment grounding conductor? Is it really done?
I haven't used it as that, but I don't think there's any exception to the bonding. It still has to be bonded.
You still have to bond
Yeah,
it.
yeah, yeah.
I just did, with the cables installed typically has an equipment grounding conductor of the wire type, even if they're individual conductors above 1 aught.
So the code says cable tray can serve as an equipment grounding conductor. Okay, fine, you know. And then we go on to wireways. People call these troughs. They call these gutters. They sometimes call them auxiliary gutters. They're called the wireway. You know? And the wireway can, if it's listed as an equipment grounding conductor, can. Number 14 is you can use surface metal raceways. We probably should get some better pictures, Mario. Make a note one day. And there's a lot of nice surface metal raceways out there that I think we got about the worst possible graphic we could on a surface metal raceway. It's close. You know, maybe not. Yeah, it's the worst.
But that's what, yeah.
It's common. I hated surface metal raceways. I hated. So they're listed as an equipment grounding conductor. I'm looking at this crap, and you're putting 90s and boxes.
That you
and
can
you're trying
barely get to stay together.
Right.
Yeah.
Yeah.
And I'm like, but theoretically, they're listed because they put it a test. They put this in here. And interesting, if you guys want to do some research, you might know this. Do you know what they do the test to get that to verify that that's an equipment grounding conductor? Do the search on that. I'll give you a tip.
About the 10,000 amp test.
30 amp. It's a 30 amp test. Research, double check me, make sure I'm right. So when they test the surface metal raceway, I think it's a 30 amp test and they do something with voltage drop. Okay, on a surface metal raceway. So double check me there. It's crap, but it's listed by the code. Okay, let's identify. Mario?
Yeah, I just want to make a comment that we just went off and listed a list of equipment grounding conductors, and in accordance with ULDWTT, those fittings for those metal conduits and tubings and metal cables are also listed for grounding.
Oh, if you buy a fitting for a wiring method, well, first of all, we're not going to cover this, but every wiring method says that the wiring method and the fittings must be listed. They're all .6s in all the wiring methods.
We talked about that during Understanding Volume 1.
Exactly right. So all the fittings and the wiring methods are listed, and they're listed for the purposes as an equipment grounding conductor with a fitting in that particular raceway.
Yep.
So that it all works. Okay.